Determining if equipment is overheating requires careful observation and comparison. Firstly, use your thermometer to measure the temperature of similar pieces of equipment operating in the same environment. A significantly hotter temperature on one piece of equipment compared to others may indicate a potential problem. Secondly, always refer to the equipment manual or datasheet provided by the manufacturer. These documents specify the recommended operating temperature range for the equipment. If the equipment's temperature exceeds this range, it is a sign of overheating. Thirdly, consider the load that the equipment is carrying. Equipment operating under a heavy load for an extended period can experience elevated temperatures. Fourthly, evaluate the environmental factors surrounding the equipment. Extreme ambient temperatures or poor ventilation can contribute to overheating. Ensure the room temperature is within acceptable limits and that there is adequate airflow around the equipment. Now let's consider circuit breaker panels and main lug panels. One key factor is load balancing. If one leg of a circuit breaker panel or main lug panel is carrying significantly more load than the other legs, it can result in higher temperatures. Ensure that the load is evenly distributed across all legs of the panel. Loose electrical connections can create high resistance, leading to heat generation. Inspect all connections for tightness and ensure they are properly secured. Using oversized conductors for the current demand can sometimes lead to poor connections and overheating. Check that the conductor sizes are appropriate for the load requirements. Grounding faults can cause excessive current flow and overheating. Use a ground fault circuit interrupter, also known as a GFCI, to protect against these types of faults. So how did you decide when a problem actually exists? A significant temperature difference between a piece of equipment or a component and similar ones under similar conditions is a strong indicator of a problem. Operating temperatures that consistently exceed the manufacturer's recommended range can also indicate an issue. If equipment overheats even when it is not operating under heavy loads, it may require attention. Look for any signs of deterioration of components. If the overheating is causing visible damage or performance degradation, it is a clear sign of a problem. Here are some additional tips. Use a non-contact thermometer for quick and easy temperature measurement. It allows you to take readings without physically touching the equipment. Record temperature measurements over time to monitor trends. This can help you identify gradual increases in temperature that might otherwise go unnoticed. And of course, seek professional assistance if you suspect an issue that you cannot resolve yourself. A qualified electrician can help diagnose and repair any underlying problems. Now let's delve deeper into the factors that contribute to equipment overheating. In addition to the load, ambient temperature, and ventilation, consider the equipment's duty cycle. Equipment designed for intermittent use may overheat if operated continuously for extended periods. Check the equipment specifications to determine its duty cycle rating and ensure it is being used within its intended parameters. Internal components within the equipment can also contribute to overheating. For example, in a motor, worn bearings or a misaligned rotor can increase friction and generate excessive heat. Similarly, in electronic equipment, failing capacitors or resistors can cause localized hotspots. Regular maintenance and inspection of internal components can help identify and address these issues before they lead to major problems. Another important factor to consider is the age of the equipment. As equipment ages, its components can degrade, leading to increased heat generation. Insulation can break down, connections can corrode, and moving parts can wear out. Regular inspections and preventative maintenance can help extend the lifespan of equipment and prevent overheating due to age-related degradation. When troubleshooting overheating problems, it's essential to use a systematic approach. Firstly, gather information about the equipment's operating history, load conditions, and environmental factors. Secondly, visually inspect the equipment for any signs of damage, such as discoloration, swelling, or melting. Thirdly, use your thermometer to measure the temperature of various components and compare them to the manufacturer's specifications and readings from similar equipment. Fourthly, check all electrical connections for tightness and corrosion. Fifthly, use a multimeter to measure voltage and current levels to identify any imbalances or overloads. Sixthly, if possible, use a thermal imaging camera to visualize heat patterns and identify hotspots that may not be apparent with a standard thermometer. By following a systematic approach and using the appropriate tools, you can effectively diagnose and address overheating problems in electrical equipment. Remember, safety is paramount when working with electrical equipment. Always to energize the equipment before performing any inspections or repairs. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electrical equipment, seek professional assistance from a qualified electrician. Let's talk about some specific scenarios where a thermometer can be invaluable in troubleshooting overheating problems. In a motor control center, for example, you can use a thermometer to check the temperature of the motor starters, overload relays, and circuit breakers. Elevated temperatures in these components can indicate a problem with the motor, the control circuit, or the power supply. In a transformer, you can use a thermometer to check the temperature of the windings, core, and bushings. Overheating in a transformer can be caused by overloading, insulation failure, or cooling system problems. In a lighting system, you can use a thermometer to check the temperature of the ballast, lamps, and wiring connections. Overheating in a lighting system can be caused by faulty ballasts, incorrect lamp types, or loose connections. By using a thermometer to monitor the temperature of these components, you can identify potential problems before they lead to equipment failure or safety hazards. In addition to using a thermometer, there are other tools and techniques that can be helpful in troubleshooting overheating problems. A clamp meter can be used to measure the current flowing through a conductor without having to break the circuit. This can help identify overloaded circuits or unbalanced loads. An insulation resistance tester, also known as a megometer, can be used to measure the insulation resistance of conductors and equipment. This can help detect insulation breakdown, which can lead to overheating and electrical faults. A power quality analyzer can be used to measure voltage, current, and harmonic distortion in a power system. This can help identify power quality problems that can contribute to overheating. By using a combination of tools and techniques, you can effectively diagnose and address a wide range of overheating problems in electrical equipment. Another critical aspect of preventing overheating is proper maintenance. Regular cleaning, lubrication, and tightening of connections can help keep equipment running cool and efficiently. Develop a preventative maintenance schedule that includes regular inspections of all critical components. This will help identify potential problems early on, before they lead to overheating or equipment failure. Keep accurate records of all maintenance activities, including dates, findings, and corrective actions. This will help track the equipment's performance over time and identify any trends or patterns. Invest in employee training to ensure that personnel are properly trained in the operation and maintenance of electrical equipment. This will help them identify potential problems and take appropriate corrective actions. By implementing a comprehensive maintenance program, you can significantly reduce the risk of overheating and extend the lifespan of your electrical equipment. Finally, it's important to stay up to date on the latest industry standards and best practices for electrical safety and maintenance. The National Electrical Code, also known as NEC, provides comprehensive guidelines for the safe installation and operation of electrical systems. Consult with qualified engineers and electricians to ensure that your electrical systems are designed, installed, and maintained in accordance with the latest codes and standards. Attend industry conferences and workshops to learn about new technologies and techniques for preventing overheating and improving electrical safety. By staying informed and proactive, you can create a safe and reliable electrical environment for your employees and your equipment. Let's consider some real-world examples of how overheating can be detected and addressed using a thermometer. Imagine a situation where a motor in a manufacturing plant is experiencing frequent shutdowns. Using a thermometer, the maintenance team can measure the temperature of the motor windings and bearings. If the temperature exceeds the manufacturer's specifications, it could indicate a problem with the motor's cooling system, lubrication, or internal components. Further investigation might reveal a clogged air filter, a faulty cooling fan, or worn bearings. Addressing these issues can prevent further overheating and extend the motor's lifespan. In another scenario, consider a server room where the air conditioning system is not functioning properly. Using a thermometer, the IT staff can measure the temperature of the servers and other equipment. If the temperature is too high, it could lead to data loss, system crashes, or hardware damage. Addressing the cooling system issues can prevent these problems and ensure the continued operation of the server room. These examples illustrate the importance of using a thermometer as a diagnostic tool for identifying and addressing overheating problems in a variety of settings. By regularly monitoring equipment temperatures and taking corrective actions when necessary, you can prevent costly downtime, equipment damage, and safety hazards. Let's explore some additional considerations related to the selection and use of thermometers for troubleshooting overheating problems. There are several types of thermometers available, each with its own advantages and disadvantages. Non-contact infrared thermometers are convenient for quick temperature measurements, but they may not be as accurate as contact thermometers. Contact thermometers, such as thermocouples and resistance temperature detectors, also known as RTD, provide more accurate temperature readings, but they require direct contact with the object being measured. When selecting a thermometer, consider the temperature range, accuracy, resolution, and response time. Also, consider the environment in which the thermometer will be used. Some thermometers are designed for use in harsh environments, while others are more suitable for indoor use. When using a thermometer, follow the manufacturer's instructions carefully. Ensure that the thermometer is properly calibrated and that the measurement technique is appropriate for the type of thermometer being used. Take multiple readings to ensure accuracy and repeatability. Record the temperature readings along with the date, time, and location of the measurement. This will help track temperature trends over time. By carefully selecting and using thermometers, you can obtain accurate and reliable temperature measurements that can be used to diagnose and address overheating problems in electrical equipment. Furthermore, consider the impact of altitude on equipment cooling. At higher altitudes, the air is thinner, which reduces its ability to remove heat from equipment. This can lead to overheating, especially in equipment that is already operating at or near its maximum temperature rating. If you are operating equipment at high altitudes, you may need to derate its capacity or provide additional cooling to prevent overheating. Also, consider the impact of humidity on equipment cooling. High humidity can reduce the effectiveness of air cooling systems, as the air is already saturated with moisture. This can lead to overheating, especially in equipment that is sensitive to humidity. If you are operating equipment in humid environments, you may need to use dehumidifiers or other methods to control the humidity level. Furthermore, be aware of the potential for electromagnetic interference, also known as EMI, to affect the accuracy of temperature measurements. EMI can be generated by nearby electrical equipment, such as motors, transformers, and welders. To minimize the effects of EMI, use shielded cables and filters. Also, keep the thermometer away from sources of EMI. By considering these additional factors, you can improve the accuracy and reliability of your temperature measurements and prevent overheating problems in electrical equipment. Remember, the goal is to create a safe and reliable electrical environment that protects your employees, your equipment, and your business.